Okay, so to use the addition and subtraction formulas found in the last video a little bit. So we'll start off with the first two. And we want to find sine of 75 degrees and cosine of pi over 12. So I'm just going to write down the addition formulas because I'm probably going to stick with just using them. So sine of 75, I want to know if there's any angles that I already know. And hopefully you still have that chart written down, the one that was pi over 3, pi over 4, pi over 6. And so pi over 3 was 1/2, square root of 3 over 2, square root of 2 over 2, square root of 2 over 2, square root of 3 over 2, and 1/2. These correspond to angles, which was discussed in a different video. So this would be 45, this would be 60, this would be 30. And it goes in order. So this would be cosine, sine. Okay, so I got my chart. And I'm going to say, do any of these add up to give me 75? Or subtract to give me 75? And they do. So 30 and 45. So I'm going to rewrite this as sine of 30 plus 45. And so I'm going to say, I'm going to use my sine of a plus b. I'm going to say sine of the first, cosine of the second, plus sine of the second, cosine of the first. That'd be 30, sorry. So sine of 30 is 1/2. Cosine of 45 is square root of 2 over 2. Sine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Multiplying to multiply straight across the top and bottom, square root of 2 over 4 plus square root of 6 over 4. Common denominator, might as well write as one fraction. Can't actually add these together though, so square root of 2 plus square root of 6. And done. Okay, cosine of pi over 12, might as well stick with it being radians. And see if I can add or subtract any of these things to get me pi over 12. And probably not adding pi over 12 seems pretty small. So I'm going to see what happens. And let's see, 4 and 3 will give me a common denominator of 12. So 4 and 6, 3 and 6 would give me common denominator 6. So probably not going to try those. Might as well try 4 and 3 first though. So I'm going to try pi over 3 minus pi over 4. Common denominator 12. Multiply this by 4, that by 4. Second one by 3 and 3. So actually, first one worked. If it didn't, I could try 4 and 6. So I'm going to write this as cos of pi over 3 minus, so plus or minus, pi over 4. So that way I get to a positive pi over 12. Okay, so my cosine, it's cosine of both of them. Pi over 3, cos of negative pi over 4, minus sine of both of them. Sine of pi over 3, sine of negative pi over 4. Okay, so cosine of pi over 3 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Negative pi over 4 is, let's draw it, down here. And cosine is positive there, so positive square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. Sine of negative pi over 4 is again down here. So it's again going to be square root of 2 over 2. But sine is negative down there. It's one of my y's. So I get that times a negative square root of 2 over 2. So I'll get square root of 2 over 4 plus square root of 6 over 4. And I made it so it was really easy to write my answer again. Both of them actually give me the exact same answer. Okay, so hopefully that makes some sort of sense. Let's just look at the last one. So we're going to move this up a little bit. The last one's a little confusing looking because it says sine of 20 cosine of 40 plus sine of 40 cosine of 20. And that's a lot of stuff. And I do not know what sine of 20 is or cosine of 40. And I could probably play with these, but I don't even think I can get 20 or 40 from them. So I'm kind of screwed. Except maybe I'm not, because if I look at that, that looks like this, doesn't it? Sine of A cosine B, sine of B cosine A, the two things being switched. Okay, so really, this is the sine of A plus B. So sine of 60. Well, sine of 60 I know. That's just square root of 3 over 2. Oh, that turned out a lot easier than I thought.